Hi, I want to talk about mean squared error. And mean squared error is a way to measure how far off the predicted outcomes of your model are from actual ones. So think about it like this. You have a training set and you're giving that training data set to a model to learn from. Now, how much it learns from it, does it learn too much so it remembers every pattern, every noise? Noise is the information that is not necessary. Or is it oversimplifying things so it doesn't learn too much, so it then cannot generalize on a new unseen data? Overfitted model is a model that learns too much from the training data set. And this is a problem because in a training data set, you want the model to learn the right amount of information so it can then perform well on a new unseen data, because you want it to see patterns, to see and actually analyze and see. But if it's overfitted, it learns too rigidly, so then it becomes basically closed-minded and it doesn't want to see a new information because it has its own basic thing about it, like it has its own world. Whereas underfitted model is a model that actually oversimplifies things. It doesn't see much patterns at all. It didn't learn from the training data that much. So basically you can have an analogy of a kid that thinks that every animal is a pig. It has these assumptions, but it's not true. And this is why we want to strike a balance between overfitting and underfitting. So I've created a model and I want to know if that model is overfitted or underfitted. We can think about it as we have a training data set, the information that the model learns from, and the testing data set, the new unseen information that the model needs to generalize on, that model needs to analyze and see and give the outcome. So basically how you do it is that mean squared error. The formula for it is actual minus predicted squared. So if we're providing the model with the training data set and the outcome will be, just imagine, 4, and we are providing it with testing data set, it's going to be 2.5, then we know that there is a big gap, and we can assume that that model is quite overfitted because it learned too much from the training data. It thinks that all the patterns should be the same patterns should be on the new data, and it assumes that and it gives us appropriate results. And vice versa, if the outcome numbers are low on both sides, that we know that that our model is like that kid that thinks that every animal is a pig or a cow, whatever. It cannot see the pattern, so it learned poorly on the training data. So this is my basically day of working with models and calculating basically predictions and actuals. Another thing I want to leave here is hyperparameter tuning. And this thing is based, the main goal of hyperparameter tuning is bias variance trade-off. And whatever I said in the previous minutes, which is you don't want your model to be overfitted nor underfitted. You want it to be right in the middle, right, like in a balanced way. This is what bias variance trade-off does. It is basically the process of finding that middle perfect sweet spot on which your model would be able to generalize well on the new unseen data, to see patterns and stuff on the data you provided with in the future. So basically the main difference between hyperparameter and parameter is that parameter is learned during the training, whereas hyperparameter, it is set manually before the training. So hyperparameter in regularization will be alpha, and alpha is a strength of regularization. So basically the whole idea of hyperparameters and parameters is that hyperparameters control the model and the process, whereas a parameter in linear regression will be bias or weights. And bias is the thing that I mentioned here before. It's the thing that basically influences how underfitted the model is. So hyperparameters are controlling the process, whereas parameters, they represent the process. Hyperparameters are defined before learning, and parameters are defined during the learning. A lot of the times I get stuck on a specific line because I don't remember the structure of the proper structure of that line or block of code. And the main idea that is behind all of that is that all this X and Y, the whole idea of building a machine learning model is that you supply a model with data, and it needs to give you in the future predictions, answers that you're gonna ask it for.